Climate change is challenging food production around the world. Temperatures are increasing faster than plants can naturally adapt, and diseases are emerging and spreading in places they have never been found before, threatening the livelihoods and food security of farmers and consumers. Agricultural scientists with the Seeds of Discovery initiative are working with two of the world's most eaten crops, maize and wheat, to help breeders around the world develop varieties with natural resistance to overcome challenges and produce more quality and nutritious food. This work starts with the seed bank at the International Maize and Wheat Improvement Center, which safeguards over 28,000 maize and 150,000 wheat varieties for the benefit of humanity. Many of these seeds are native maize and wheat varieties, passed from generation to generation for millennia, known as landraces. Each landrace adapted to grow in different environments, developing resistance to different climates and diseases. By including these native varieties in breeding programs, scientists and farmers can improve the strength of crops to stand up to climate change. However, with little field and genetic information on all the different seeds in the bank, it can be difficult to find varieties with a certain quality, like drought tolerance. Scientists with Seeds of Discovery are characterizing the genetic makeup of these maize and wheat collections using modern DNA sequencing technology and are measuring their performance in field and laboratory trials. Combined analysis of these data will speed up the identification of landraces with useful genetic diversity for priority traits like heat tolerance, and thereby accelerate the development of new, improved crop varieties. The data are freely available, along with innovative software tools that can help crop breeders use this crop diversity more efficiently. The information and tools have already been used in the fight against deadly maize diseases, ravaging farmers' crops and threatening food security. Maize lethal necrosis, or MLN, is a disease that has devastated maize production in Eastern Africa since its detection in Kenya in 2011. MLN causes leaves to dry up, causing premature plant death and unfilled, poorly formed cobs, killing off the harvests of many farming families.
These are mostly subsistence households, so a big outbreak of MLN can affect their diet, but it also affect whether the children are able to go to school. It's an instability both in food security and just the overall economic well-being of these farmers.
Nearly all maize varieties in the region are susceptible to MLN disease, and farmers require fast action to save their crops. Using the Seeds of Discovery tools, scientists analyzed over 1,000 native maize varieties from areas of Latin America where variants of the disease are known to be present. They identified 20 varieties that showed promising signs of resistance. These are now being included in breeding programs to develop new maize varieties that are resistant and maintain the qualities farmers enjoy. The ability of the Seeds of Discovery tools to cut down the time it takes breeders to identify seeds with the traits they desire is crucial, as climate change is expected to increase the frequency at which plant diseases move into new areas.
So climate change is definitely having effect, not just on MLN, but all diseases, and it will certainly cause more diseases to come into areas where they weren't seen in the past.
In addition to disease, climate change is also affecting global temperatures. Every 1 degree centigrade increase in temperature decreases wheat yields by 6%. However, demand for wheat is expected to increase by 60% by 2050.
So sometimes if you have too much heat stress, that trigger the plant system to mature faster, and then there is not proper grain filling, and that ultimately affects the production of wheat.
Seeds of Discovery is looking back to ancient wheat collections from regions known to suffer from extreme heat, such as parts of Iraq and Iran, to identify wheat landraces capable of tolerating high heat stress. 70,000 varieties were tested for heat tolerance, and the 1,000 most promising varieties are being used in breeding programs around the world, including Mexico, India, and Pakistan, to develop improved heat-tolerant wheat varieties that will help farmers better adapt to climate change. By conserving crop diversity and using modern technology to explore and identify its use in breeding, the Seeds of Discovery Initiative is working to improve livelihoods and ensure food and nutrition security for maize and wheat farmers and consumers.